we have seen data sharding and partitioning. And because of the same topic, I thought of maybe it is better to continue with something that is related to database. So this topic is mainly related to database when we have a distributed system. So as you all know, distributed system is distributed across all over the world and through the network, especially the internet that we use. And we need to understand CAP theorem is because it is a foundational principle for understanding the limitations of distributed system. So that is the important factor here. Because when you design your system, you need to understand that what is CAP theorem, what are the constraints related to it, and when you design, you need to consider a few factors to it. And that is what we are going to look at it. So CAP theorem is just, there is a full form for the CAP. And as let me just zoom a little bit so that we all can see it clearly. Okay. So CAP stands for, like C stands for consistency, A stands for availability, and P stands for partition tolerance. So here I have shown some kind of diagram. You can, if you Google it, you will see the similar diagram all over the places if you talk about CAP theorem. So CAP is just a combination of three things. It's either you can choose consistency and availability when you design your system, consistency and partition tolerance, or availability and partition tolerance. So I just marked in star here that partition tolerance can always be part of your system. That we'll look at it because that's the important topic that we'll discuss next. But here you can see that even the circles that I have drawn here, you can see there is an in-between overlap between these circles. So this is just to show that you can either achieve consistency plus partition tolerance or availability plus partition tolerance or consistency and availability. So out of which partition tolerance always be there. And when you design your system, it will always be there. So mostly we design for CP or AP, that is consistency and partition tolerance, and availability or partition tolerance. So let's understand it better in depth that what exactly is partition tolerance, maybe consistency and availability we have already seen, but we will also look at those two topics. Okay, so let's understand partition tolerance first. Okay, so just look at this diagram that I have mentioned here. See, partition tolerance, these are two different words. So we need to understand what exactly partition first, and then we'll understand what is tolerance. So just look at this diagram. I have just put some database symbols here, and they're connected or interconnected with each other. Just take an example that maybe it's a database of YouTube. Just a very simpler example. I'm just trying to, the diagram is very simple, but YouTube will have a very complex system behind it. But just take an example. And this database is placements. These all nodes of database are placed across multiple locations in all over the world. Maybe some databases are located in US, some in Europe, some in India. So, and they are interlinked with each other. Why? Because there is continuous read and write happening. Maybe someone is uploading video from India, someone is uploading from Europe. So, and that videos are also replicated to multiple locations. So anything that is uploaded in US, it will immediately available in India or Europe. So that is happening all over the world. And you can see that this database, like whatever communication, whatever this transaction of reading and writing of data is happening over network. So all these lines, arrows that are pointing to each other in this database are actually the network that is communicating, like reading and writing data or replicating the data. So that is all happening over the network. But what if any of these network lines or network between these database gone down? So I mark this in this red cross, the blue cross in the red. So that is kind of showing that maybe there is a network failure. Failure can occur anytime. It is inevitable to control the failure itself. It has always been there. Maybe some disaster, maybe some network failure due to maybe cable or some other reason, but it will always be there. You cannot avoid the network failure. So when there is a network failure between the communication that is happening between databases, that is called partition. So it is not like database partition that we talked about. It is actually the failure between the network and between two nodes. So if the node goes down, or the network goes down, then the communication between these two nodes or the database will fail. And that is what the partition between the databases. And you cannot avoid this partition. So that's why I mentioned earlier that when you design a system, partition will always be part of your system while you design system. You have to give consideration, or you must include partition when you're designing system. Okay. And partition tolerance means the system continues to operate even the network failure is there. But it is there are some trade-off or choices that you have to make while design system, that if there is a partition, how I should respond to it as a system designer, that how what should work, what should not work. So there this choice that we have to make, and that is where we have seen previously that we have to choose consistency or availability. So there are two systems that we said that those system always will be there, like CP and AP. There's consistency and partition tolerance, and availability and partition always you have to design according to that. There will be consistency and availability, but we'll look at it. This example, I don't want to say, I want to show it so that you can understand better. But I hope partition is clear. Again, I'm repeating, partition is the failure, the network failure between two nodes that is stopping the communication between two databases or two components. It may be any other thing, but right now we're talking about database. And partition tolerance is how tolerate your system. That means how, even though there is a network failure, your system is still working fine or serving the purpose. All right. Let's understand the next important aspect. We have seen partition tolerance now. Let's look at consistency. See, this topic we already have seen our previous sessions. Somewhere we talked about consistency. I can show you that. I think these are the topic that we discuss. Okay, we have seen strong, eventual, and weak consistency. We have seen some of the example of it. So this is the same topic here. I'm just trying to give you a quick example on that. So that's why I put this diagram so that I can explain it better. See, here we are talking about a financial transaction. Okay, I'm just putting some nodes here, calling it as ATM located multiple location in India. And I'll give you an example, but this here we are talking about is strong consistency because we are dealing with financial transaction, and financial transaction always need a strong consistency. So here I'll explain the points that are mentioned in right side later, but let's understand. Suppose I am located in Pune and maybe my friend is staying in Delhi and another friend staying in Mumbai. So if using ATM, usually we do it online with online banking system and all, but just imagine that by using ATM, I'm trying to transfer some amount to my friend in Delhi. So just imagine when I do the transaction that in ATM located in Pune, closer to my location, immediately that transaction, whether I'm transferring some amount to my friend's account, so amount will get deducted from my account and it will get credited to my friend's account. So that transaction, the full transaction will be returned to some database, which is maybe closer to my ATM or closer to my location. So that will be returned to that. And then maybe in 5 minutes or maybe 10 minutes, my friend, he went to ATM located in Delhi and he will check his account and he will say that, yes, he able to see that the amount has been credited to his account. So that is an immediate response. Same for even Mumbai location. My friend will able to immediately see that his transaction is completed. He or she has received the money. So that is why this is happening, because there is a continuous replication happening between these database nodes. Whenever my transaction is finished, immediately it is replicated to the other nodes of the. Right now it is shown only 3 nodes, but it may be hundred or thousands of nodes spread across the country itself. So this is something that is called strong consistency, because at any location, anytime any transaction that is happening, it will be immediately visible on the other areas or other nodes as well. So this is an important that data is consistent at all locations. Here, that's why the definition is mentioned here. All clients or nodes see the same data at the same time, no matter which node they connected to. So anyone connected to any node, they will see the same data. So that is what the consistency. And here we are talking about strong consistency. We have seen the eventual consistency like YouTube video count, view count, which is okay if you're not able to see immediately. Maybe after 1 minute or 10 minutes, that's still okay because it is not going to impact any of the business rules. It is not something that is very important for the user. But for financial transaction, definitely if the transaction was replicated, immediately there will be confusion, there will be frustration. So that's why this kind of consistency is necessary. So you have to decide, see again, you have to choose over consistency and availability. Both has positive side, both has negative sides. Okay, so let's look at some points, then we can discuss further on this. See, it is achieved, as I mentioned earlier, that by updating several nodes before allowing further reads. So we will not read from any of the databases until all the nodes are updated with the latest information. And if there is a partition, something failed, then there will be inconsistent data. And if there is inconsistent data, then there'll be either unavailability or maybe there will be wrong information to be passed on. But in case of financial transaction, again, I'm mentioning it is very important to have strong consistency. And again, you have to choose consistency and availability, but it all depends on system to system or the use case that you have. You have to make that trade-off, that how to design your system, what is the purpose of your system, and what kind of approach that you will take. It depends on organization or the particular use case. Okay, I hope this is also clear. Let's look at one more example so that we will be better clear about it. That is something related to availability. See here, I'm just giving the same example, but in this example, there's a partition. I already marked it as cross. So I am doing transaction in Pune. It is written to the database that is closer to my location, but that node is got disconnected with the other nodes. So there is no replication that is happening. So as I mentioned earlier, then my friend in Mumbai or Delhi, they will be frustrated because even I also will be frustrated that I finished my transaction. I have transferred my amount. The amount got deducted from my account, but why it is not reached? And then there'll be kind of confusion. So in this case, like for this particular scenario, that means the system is available. That's why my friend in Delhi and Mumbai getting the wrong information. They have not received the information, and they checked in the ATM and they say that okay, the amount is not been credited into their account. Why? Because the ATM is available. The node to which that ATM is connected, that is available, due to which they are getting inconsistent data. Why inconsistent data? Because of the network failure, the data is not replicated, but still database is available. So database is giving what information? The older information, the information that is not updated. So again, because the data was not consistent and still the system is available, the other users or other friend of mine are receiving wrong information. So then you have to decide on this two part, whether you want to give a consistent information to the user, then you have to make sure that you have to, until unless the data is not replicated and the network failure is not resolved, till that time you have to keep your system down. That is another problem also. See here, as the definition say, availability is any client request for data, they should get immediate response, even though any of the node that is down. So here, my friends in Delhi and Mumbai, they are getting response because they are connected to the database, ATM is available, and they receive the information. But that information is not updated with the latest data or latest transaction. So here, in case of partition, the system is still available, but the data is inconsistent. So that means the available data is not getting the latest information from the other nodes due to network failure. Okay, so you have to make sure that data, if there is a strong consistency needed, then the data, all the nodes should have same information at the same time. Until and unless the information is not replicated to all nodes, you have to bring your system down, or maybe there will be latency issue. You will get information, but little late. Okay, so that's why sometimes, no, when you go to an ATM machine or try to withdraw some money and you see the system is down, you can see some message on ATM machine, system is down or system is not available. That may be one of the reasons. I'm not saying that is the only reason. It may be multiple reasons, but one of the reason is data is not inconsistent. So again, you have to choose here what your system is needed. Whether you want a consistent data, then you cannot have full availability. If you want availability, you cannot have consistent data. You may have to give the older information if your system is always available. So that is a kind of trade-off that you have to take. And again, as I mentioned, it's depend on system to system, use case to use case. Okay, if it is as we discussed earlier in this chapter, where we are seeing that how the strong consistency we can achieve, and what is the use case, that is a financial transaction, because it is crucial for correctness. We have seen eventual consistency where we have seen YouTube video count. It's not that important for user. So that's why it is slowly, maybe after 5 seconds, maybe after 15 seconds, the count is keep on updating. Okay, so that is how the consistency and availability is considered when we design system. Partition tolerance has always been there. Okay, so we have seen two kind of system, whether we have to choose either consistency and partition tolerance, and there is something called availability and partition tolerance. So partition tolerance is always there, but you may ask that then what about consistency and availability? Why cannot we design such system which will not have, see, partition tolerance still will be there, but still, if you think about, okay, why can't we design a system? So let's look at that part. So here I'm talking about consistency and availability for a system. If you look at this diagram, it will clearly show that now the system is not a distributed system. Why? Because all the nodes from different regions of the country are connected to a single node or single database. Maybe there is a replication happening besides it so that we can take over. Like if this single node goes down because of single point of failure, maybe another node can take over. But there's only single node that is at a time serving the purpose. But this is not a distributed system and it will have a lot of issues. Maybe because if system goes down, there will be latency issue. If system go down and some data is to be written to it, that data is not written, so that it is possible there will be kind of data loss. And this is a central node for entire database system. And it will be a kind of chaos for the user because there will be a lot of delays happening if we have these kind of system. And again, you have to make sure here the data is always consistent. The system is always available, both because we are talking about consistency and available. So to have a consistent data, all the read and write operation should happen consistently and it should be replicated also so that we can take care of the system for availability. But that is happening only with the one node. And if that one node goes down, you may have latency issue or data loss as well. And as we have seen, this is not a distributed system because distributed system is mainly to give user quicker response. But you imagine this one node is located somewhere in the middle of the country, maybe somewhere in Kolkata. Just take an example. It is located there and data is pulled from Pune, Delhi, which is maybe thousands of kilometers away from that location. So you can see that what kind of latency you will get. So that's why, and again, the network failure will be there because for far distance, you are communicating through network. So there is a possibility that network failure will still be there. Okay. So this is about consistency and availability. So I would like to repeat that, see, at the right bottom corner, I mentioned that CP and AP, consistency plus partition tolerance, or availability or partition tolerance, these all depend on the context of your problem that you are trying to solve. Okay. And also you have to choose your database accordingly, because even that also is important, that what kind of database you have. See, SQL, that is relational database, and NoSQL databases have their own advantages and disadvantages. And accordingly, you have to make choice of these database nodes. Maybe for financial transaction, you need SQL database because SQL database some property called ACID. So that property is needed so that whenever a transaction is when it is fully complete, then only it will be considered as the transaction is ready. I mean, transaction is fully done. And see, as we have seen in this case, when I am doing some transaction, I'm not just sending the money. It's like some amount is deducting from my account and it is getting credited to some other account. So that's a full transaction. So in that case, you need a database like SQL, which is a relational database, any relational database, in which you can take care of this because it has a property called ACID, which we will look at in our next session. And there is NoSQL database also needed because there are use cases where you have to decide on, okay, you want your system to be available always, even though there is no consistency of data. That's fine. So you have to make that choices. Again, it depends on the problem that you are trying to solve. Okay. So this is about consistency and availability. So again, I'm mentioning this is an important topic. We will get into more details of it. But when you are designing a system, you should know that what is CAP, what does it mean? And when you design a system, you have to think about what do you want. Partition tolerance always will be there. Network failure will be there. You have to choose the next part of it, whether you want a consistent information to pass to user or whether you want your system to be available. Okay, so that is all I have for today.